So we're going to go over a little bit of review for section 1.2, which is going to cover what is an equation and how do we solve them. So we know from the previous lesson that an equation is a statement that two quantities are of equal value, and a lot of times we think of them as a balance, right? That's what we have right here. If x plus 3 is the same as 5, that means the left side weighs as much as the right side. So we know a lot of things already, like for instance, if I was going to subtract 3 from the left side, I would have to subtract 3 from the right side, otherwise it wouldn't be balanced anymore. So we know the general idea of an equation, but what I want to talk about is how does your teacher make it? So when your teacher makes a test or something, or comes up with an equation for an example, how do they do it? And to be truthful, I don't just randomly guess. I don't say, 3x minus 12, I hope that equals 24. Sometimes it works out nice, sometimes it doesn't. So what do I do as a teacher to make an equation? Well, what I do is I actually pick the answer first. So let's say for this example, I want my answer, I want my number to be 12. It's not really much of an equation if I just tell you the answer is 12. So what I do is I disguise the answer that I want you to find. So I do a bunch of stuff to it. So let's say the first thing I want to do is I want to multiply it by 3. And then I also want to subtract 5. So again, I'm disguising my answer. So I'd take 12 and then I would multiply it by 3. That gives me 36. I would take that 36 and then subtract 5. I'd be at the number 31. So however many things I want to do to disguise it, once I get the answer from doing that, I tell you. I say, okay, the answer after a disguise is 31. And then that's how I come up with an equation. I don't obviously write it in words, so I write it in symbols. I pick a number, and I don't want to tell you what that number is, so I call it x. And then what I do is I perform the operation. So I take that x and I would multiply it by 3, and then I would subtract 5, and then I got the number 31. So again, I come up with the answer first, and then I do a bunch of stuff to it. Now, why would I care to share that with you? Because if you know how I make an equation, you can then use that to help you solve the equation. In other words, go backwards. So let's say we were looking at an equation like 2x minus 13 was equal to 3. Let's think about the teacher for a second, the teacher that made this problem up. What did they do to make this? Well, the first thing they did was they picked a secret number. Right? I don't know what number they used in this equation, so I want to find it. Now, that secret number they picked, they called it x. Now, the way that they wrote it, I just have to go ahead and follow the order of operations. I included that over here. We know what order to see these operations performed in. So when I look at the original problem, I see two things. I see this was multiply by 2. And then I also see a stage of subtract 13. According to the order of operations, multiplication would have come second. So that must have been the second step, was multiply that secret number by 2. And then the third thing they must have done is they must have subtracted 13. That's what the teacher did. They picked a secret number, called it x. They multiplied it by 2, and then they subtract 13. Now, starting with their secret number, they get 3 if they do all of those things to it. So what would a student do? So I'm going to just copy another version of the equation. We'll do it right here. So what the student needs to do is the student needs to go backwards. So instead of ending with the number 3, a student has that as their first clue. So I need to start with 3. Now going backwards, if the last thing you did was subtract 13, I want to undo that step. So the opposite of subtracting 13 would be to add 13. If you multiplied it by 2, then I'd want to divide by 2 to undo that. And then if you picked that secret number and I undid all those steps, I should get your secret number back. So see how I undid the steps in backwards order? I undid what they did in a reverse step. So I can just do this in my head. I don't need to be fancy with how I show it in my equation. So I'm going to start with 3. I'm going to add 13 to it. That gives me the number 16. I'm going to take 16 and divide it by 2. That gives me 8. So 8 would have been my secret number. So let's see that a little bit faster with another example. So when I look at an equation, the first thing I want to think about is, what did the teacher do? And we know that when teachers make equations, the first thing they do is they pick a number. Now in this case, the teacher called it W for some reason. Now they can call it whatever they want. So here's that number that they picked. Now again, following my order of operations, looks like multiplication and division come before addition and subtraction. So after they picked that number, what they wrote down to me was they multiplied by 3. And then the last thing they did was they added 7. Now if I do that correctly, or if the teacher did that correctly, starting with their secret number, multiplying by 3 and adding 7, they should have ended up at the number 19. So what I would need to do is I would need to undo those things. Now we're going to also transition to, how can I show my work here? So they ended at 19. So if I want to undo it, okay, I already have 19 in my equation, so I've undone that step. I'm going to start with that on the right side. So how do I undo adding 7? Well, I would have to subtract 7. And again, this is where our balance plays in. If I subtract 7 from one side of a balance, for instance, let's say the numbers 10 and 10 were balanced. If I subtract 7 from one side of the balance, I have to subtract 3 from the other side of the balance, otherwise they're no longer balanced. So in other words, we subtracted from both sides. So I undid that step. So if they multiplied by 3, I don't want W multiplied by 3. I would unmultiply it, or in other words, undo it by dividing both sides by 3. So after I undid that, I should be at a number called W, and I am. So looking at another example, let's go backwards from what the teacher did. So we can see here that a teacher, when making an equation, would always start by picking a number they want for the answer. And in this case, it looks like they called it D. Right? They don't want to write the number, otherwise the students would be able to guess what the answer was. So here we do see a fraction, and I would remind you that the top part of a fraction has a little set of parentheses around it, and the bottom has its own set of parentheses. So it looks like the first thing they did, because that D minus 8 should really be in parentheses, is it looks like they subtracted 8. After they subtracted 8, I can clearly see they divided it by -2. After they performed those steps, they got the number 12. So as a student, what would I have to do? Well, I would have to start with the number 12 as an equal sign. So we have that there already. Now, the last thing the teacher did was divide by -2. So how would I undo that? Well, to undo dividing, I'm going to multiply by -2 as well. The way that I'm going to show that, so I'm just going to put times -2. Actually, I'm going to put it in parentheses to show multiplication. So I'm going to multiply the left side and the right side by -2. So 12 times -2 is -24. Now on the left side, recall the whole reason that we multiplied by -2 was to undo dividing by -2. So those two things should undo each other. We'd be left with D minus 8. So we undid that step. The teacher subtracted 8 to disguise their number. So I'd want to undo subtracting 8 by adding 8. And again, I have to do it to both sides. So the reason I added 8 was to undo the subtraction of 8. So I'm left with D. Now here, -24 plus 8. So 24 and 8 are 16 apart, but there's more negatives than there are positives. So -16. So the answer is -16. Our last example for today is 8 divided by 3 plus 4 is equal to 6. So again, I always like to think about what the teacher would have done to make a problem like this. The first thing a teacher does is always choose a secret number that they want their students to find. And in this case, it looks like this teacher called it A. So I like to identify where that is. Here's the number that, here's the number that I need to find. Now, following the order of operations again, we can see that A was divided by 3 and added 4. So the first thing that would have happened in the order of operations is the teacher would have divided it by 3. The last thing that I can see was done to this problem was they added 4. Once you do those steps, if you started with the correct number, you should get 6. So as a student, what would I do? Well, I start with what was given to me. So we have 6 on that right side. Now, if the teacher added 4 as their last step, I should undo that as my first step. So the opposite of adding 4 is subtracting 4 from both sides. I'm going to shift my work a little bit. So the reason we subtracted 4 was to undo the plus 4. So on this side, we're left with A over 3. And on the right side, 6 minus 4, of course, is 2. So then finally, the only other thing the teacher did was divide by 3. So if I want to undo dividing by 3, I'm going to multiply both sides by 3. And again, it's nice to notice that the whole purpose that I wrote this times 3 on the left side was to undo the dividing of 3. So when I multiply those together, they should undo each other. So we have A is equal to 6.